with replication. You can read around this. So there's independent to factorial, there is repeated measure factorial. So this one that we're using. So you click on OK, and then you select the input range from here, and then you select like this. And then how many rows per each sample? It means that there are 1, 2, 3, 4, 5, 6. So 6. If you have 7, you type 7. If you have 8, 8. And then if the alpha level is 0.05, you write that. If it's 0.01, you just click there, backspace, and type 1. And then I think you guess, you know what is an alpha level that we're living with, like 5% chance of an error, something like that. We are 95% confident that our results are not by chance. And then you click on OK. So what I usually do, depending on your question, I right click and format the cells to convert in 2 decimal places, because most of the lecturers, even they ask you to round off 2 decimal places. But like what I said, it depends. Okay, and then you can also drag these two so that you can be able to read what is within your cells. So we are going to have, if you read around the 2-factor ANOVA, factorial ANOVA, you are going to see that you're going to meet, you see where such phrases such as main effect and then interactions. So in this instance, factors variables are referred to as factors. That's why it's a 2-factor. It means that we have 2 independent variables. What is important? This you can read on your own. How can you make use of this? But I'm going to make use of this average in a minute or 2. But what is important is this last ANOVA table, that what tells us what is important. ANOVA studies that you look at, is there significant difference in the sample? So you can change here. The sample is the major one is age in this example is age, and then the columns, those 3 conditions. So you can even type the real conditions. Okay, I'm left-handed. I struggle to type this, but it's okay. And then the interactions. It means that the interactions of age and the real. Let me just type age. The interactions of age and real conditions. So that is the other thing that is there. And then you can proceed. You can delete this other thing. So you can delete. So what matters is this significant difference, like with age and then other real conditions. You can see that this is less than 0.05. So this is significant. It can be younger and the older. And then also with the 3 conditions, there's a significant difference. But with the interactions, there's no significant interactions. I'm going to show you what does it mean. And then some of them, they ask me, where did this 1 degrees of freedom come from? So if it's a manual calculation, this F-crit is checked under the degrees of freedom of 1 and 30. And this one, degrees of freedom of numerator of 2, denominator of 30, as well as this one and this. So this one mean there are 2 conditions, the age, mature, or younger and mature. So 2 minus 1, the answer is 1. The real conditions, we have 3. So 3 minus 1, that is 2. And then the interactions, also we have 3 interactions. And then it's 3 minus 1, that's 2. And then the 30 means that for each set of 6 is 6. So 6 minus 1, 6 minus 1, 6 minus 1 times 5, that is 30. That way this is coming from. Yeah, only that. So if there's a significant difference, you can proceed and other things. But for now, I'm going to show you how do you see visually if there are interactions or there are no interactions. So although it is important to report on the significance of these 3 hypotheses, it's also important to, so what you do, you report, when you report in APA format, like what you do in ANOVA, you put on the F, including the degrees of freedom, and then if there is a significance. So the P is going to depend on how you write it. But what is important is the people like these interactions. So if there is no significance, it means that the lines are para that word is it parallel? Parallel. Yeah, something like that. I think you know what I'm talking about. So let me show you how do you identify. Let me copy this. Let me try to be as quickly as possible. Copy. And paste here. And then for the other, so this for the younger, and then for the older students, for the mature. And copy, and then paste. So this is the younger, and then this is mature. So I want to show you the interactions if they are significant. So instead, I want to have those line graphs. So this, yes. Let me just make it dark so that everyone sees. So if there is no significance in the interaction, means that these two, it doesn't matter if someone is young or mature, it doesn't change anything. It's not interacting in the real conditions. However, it can be a significant interactions. For example, if this is 8.0, yeah, like that. And then let's say this one is 7.0. Okay, so this is a significant interaction, but you don't have to interpret only on the overall, but you have to check also how are the interactions, is it uniform, if there's something like that. But I think you can read for yourself. I think I've helped. So this is, yeah, two-factor Factorial ANOVA. If, yeah, this is our video, we can learn together and then try to see how can we improve ourselves. Thank you for watching. I wish you all the best in whatever that you may be doing. Thank you.